So that was his first postulate, the principle of relativity. Laws of physics should be the same in every inertial reference frame. Second postulate has to do with light. This was a big jump. This is kind of like next level thinking. So the 19th century, physicists thought that light traveled through this stuff like an ether. Why would they think that light travels through an ether? Well, it's not all that different from like a Higgs field, if you think about it. Nowadays, physicists believe that there's a field propagating since the Big Bang that's been, that basically allows particles like leptons to gain mass. It's not the only source of how things get mass, but it does, in theory, in the standard model, it's how leptons get their mass. Anyway, back then, they believed that there was like this field called the ether. And I'm not saying that the Higgs field is fake either. There's some people who do say that, but I'm just saying this idea of there being a universal field is still around in physics in different forms today. In their day, they had it associated with light. And they said, well, you know, you've got this nice little ripple in a pond, but what's the ripple actually caused by? Well, it's caused by the water itself. So the ether was supposed to be this stuff that was allowing the light to ripple. And Einstein just says, nope, not needed. Light is different. Light has this other nature. Now, why is that true? Why does light not need a medium to propagate? It's because of quantum mechanics. Because they didn't know this at the time, and Einstein didn't really know it either. But everything is a wave/particle duality, including light and including objects with mass, including like electrons and things. It's because the fundamental building blocks of nature are fields, and what we see with this macroscopic world is trillions upon trillions of field interactions that give us the world that we see. But at the fundamental level, it's a field. And light, because it's a field, it behaves this way. It doesn't need a medium to propagate because it's an electromagnetic field. So that was his postulate. And they did this experiment, Michelson and Morley, and they did it, I think, in California, where they looked at if there was an ether, there should be a way to measure the motion of the Earth relative to the ether. So they measured it, and they found nothing, no change. So that added fuel to the hypothesis that Einstein had about light not needing an ether to propagate. So his conceptual leap, where he got it from, was recognizing that if Maxwell's equations are valid in all inertial frames, then the speed of light in a vacuum should also be the same in all frames and in all directions. So he used Maxwell's equations. He didn't just come up with this out of magic, out of thin air. He started from a very reasonable, common sense hypothesis about the laws of physics being valid in every reference frame. And then he said, well, he found a clever connection through Maxwell's equations, because remember, Maxwell's equations have the speed of light everywhere in them. They're all over the place. So he spent all this time, all these days and years, couple years, looking through all these equations and saw, hey, in order for these equations to actually be true, this can like never change. If this changes, all that we see is incorrect. So when people would do these like experiments, they would do experiments and they would say, hey, this scientist in some country, he found that the speed of light is not constant. Are you worried about this? And he'd laugh and say, no, I'm not worried at all. He was completely confident, because it's like if this wasn't the case, then none of these laws would have been discovered to begin with. It's like seeing the forest through the trees. It's like a big, giant thing that's staring right at you, but it's so hard to see it until you do see it. It's like genius is hitting a target that nobody else can see, right? That's the famous philosophical quote about it. So